you guys are seeing, this is the bioreactor, the pre-existing bioreactor that we refurbished. And what you're seeing right now is
Ahí se
it
me
is
quedó
in
ahí
process
atrás.
of it's being processed with fermentation. This is the control panel. There are readings right now showing on your fermenter indicators, which are your sensors here, measuring temperature, pressure, CO2, and telling you how much volume is in there. You also have your fermentation time, and then you have your process configuration, just as you had seen on the presentation slides. What we're gonna do today, we wanted this to be running so you guys can witness the production of bioethanol happening right now. Because once this is done fermenting, usually what we do is get that hydrometer and we take a measurement of ABV. So before we had shut it down and showed you the mash tun, we wanted you guys to see how this bioreactor operates before that bioethanol is produced with the feedstock. As you can see, the feedstock is located here and the yeast is located here, and it's all for loading purposes. So basically, what comes out of there is going to go into here, and then what comes out of here is going to be bioethanol, in simple terms. So we're going to proceed now. If you guys don't have any questions about what you see here, to moving into the mash tun batch process, we're going to set up the operation, upload the program, and show you all a quick demo of how that one works too. But we'll have to power this one off before doing it. So does anybody have any questions on what they see so far before we shut it down for a little bit? Okay. So we'll proceed to shutting down. Let me just press stop. Then press stop on that one, and then stop the data logging. All right, and then I'm gonna disconnect.
Oh, okay.
And I'm gonna disconnect the power. Okay, and then I'm going to connect the MyRio back again, so it has connection. And now we can upload the mash tun batch program. Yeah. It's recognizing the upload, the different upload. Okay. So now the program is running. We're now going to be able to turn on the power. Don't start it, don't start it. Yeah, so we're gonna move things quickly. It normally doesn't go this quick, but for demo purposes, we're gonna show you guys how it operates stage for stage. So we can move things right now it's like at 68, so we can allow it to get up to about 80. Yeah. And then minutes, we can just do 2 minutes. Put 0 for seconds. And then minutes. And temperature, yeah, that's on peak button. Cooling temperature.
So right now we're specifying all the set points which you would do before you start a batch.
These would be based on your recipe of how you want to make your feedstock for this bioreactor. There are lots of different recipes.
We can go ahead and start it. Right now the pump is turning on and it's filling up the first tank, which has a floating level sensor in it. And that level sensor is transmitting back over to here. Takes a little bit.
So these are the readings. It's probably quite difficult to see, but right now what's happening is that the level sensor in that first stage is increasing value here. And once it gets to 3 gallons as specified, it is then going to be able to turn on the heating element. And as shown earlier in the presentation, we have the lights flickering for when its control element is on or it's off. So now the water pump turned off, the lights turned off, the heating element just turned on. So we have an indication that it's on, and the temperature now is beginning to rise.
Maybe for the purposes of keeping it low quick. Go ahead.
So for
Lower it.
purposes of the demo, we're going to lower the temperature so it can move on to the next stage.
Leave it about there.
68.
68.
Okay.
So we have it set to 68 degrees right now, so it'll start going into the next stage once it hits that. Right now it's at 67 and a half, and as it goes up, eventually it'll trip and it'll cause a valve that you can't really see too well from here, but there's a valve here that'll start to open and allow it to flow into the next tank. And then also on each tank, you can see right here, you might not be able to see it there, but there's a thermocouple right there on each one of the tanks that transmit the temperature signal.
So right now it's getting close to 67.5 and it's rising.
There it goes. Does anyone have any questions while we're waiting for it to heat up? Now it
Okay.
just triggered.
So now the process status is showing it's now in stage 2. You had seen it was in stage 1, now it's in stage 2. That valve, as Graham was stating, is now open.
It also opens kind of slow.
Yes. You can hear it now opening, going into the second stage. The heating element in the second stage is not on right now. It won't turn on until the level in this one reaches 0. And how will we know that is because we have our level sensor telling us that in the first stage it's going down. So while that happens, we wait a few seconds and then the heating element.
You should also know the set point for this one as well.
Or in minutes.
No, the temperature. Or to maybe 70.
Did you fill it with full 3 gallons in each one of them?
Yeah, there's full 3 gallons in there right now.
Any questions so far on this stage, on this transition?
Is the valve a solenoid valve or a control valve?
It's an actuator valve. So it's supplied a voltage and it slowly turns its, what would you say?
It's a linearized ball valve.
It's now approaching to turn on
And there goes the
Okay.
heating element.
So the heating element just turned on now for stage 2 of the cooking. So now all the water is out and we have our water now heating in there. That is where we would start, well, we would have preloaded the grains and that's where
Yeah, this
it
is-
would have started cooking and eventually having a reaction.
And also at the same time, we have this agitator control, like we mentioned earlier, that you go ahead and increase the duty cycle and you'll start to agitate that. And I think for our purposes, we might lower it a little bit down to 69 so it can go ahead and.
You can lower the, well, in minutes, it's actually gonna flip to the next stage. Once this reaches 1 minute, it's already about to reach 1 minute. It's already at 90, I mean, 0.90.
Once it hits that 1 minute, it opens it. And the way that we have it set up, it's already below 60. The way that we have the logic set up is once the temperature goes, or the solution goes down into the next stage. If the thermocouple reads a temperature that's higher than this set point, it'll turn the valve on. And the way we have it set right now, it's set at 60. And I suppose that the room temperature is above
that. So that's why when we went to stage 3,
It
the
just
pump
turned
turned on. So it's doing what it was told to do with the logic program and developed for the system.
But currently the valve open, it's starting to flow at the same time it's pumping water through the chiller.
So this is where our finished product would be going into where we cool it down, so that way it'll get to a desired cool down temperature so we can collect it and then be able to move it into the feedstock tank.
From here we can just come over here, and once it's cooled down, we can open up the valve. It'll flow out into our bucket where we can take it and put it directly into that bioreactor. So more or less, that's how our system works.
You put in the bioreactor that we're talking about, putting it in the feedstock?
In the feedstock, yeah.
Yeah, feedstock.
You want to go ahead and show off the system?
Yeah. So relax, we can shut everything off. As you can see, everything has turned off now completely. That would be our finished product from the mash process. We will later move it to the feedstock and then run this, just as you guys had seen earlier when y'all came in, it was running, it was fermenting. So we would go back to that and then eventually collect the bioethanol, test it with a hydrometer, get the alcohol by volume content.
Well, the specific gravity.
By using the specific gravity as mentioned in the presentation.
And what are we gonna do with all this stuff?
How do you mean? The water right here?
The mash,
We'll dump that out.
The feedstock to the bioreactor.
we,
We'll ferment it,
Process,
ferment
and
it,
how
and
about the
process
product
it.
of the bioreactor?
The product of the bioreactor we would like to further refine.
for the
Okay, and
refined
what,
distillate.
who's gonna refine it?
Oh, yeah.
Michael? Where is the other team?
Yeah.
So we have this equipment here to refine the
They refine them, yeah.
product of the bioreactor.
Con eso va a venir para acá, va a ser otro project.
So it all runs together. It starts with this one, goes to this one, and then it gets
goes to
refined
the-
in that one.
refined that one.
And
Wow.
hopefully we're gonna be able to sell, I guess, to those mega companies.
Yeah.
And you can use it
When do
in
we
your
come
car.
back to sample?
Yes, yes. I hope you got a good idea about the project that
It's really
this
nice.
team completed. Actually, it's a continuation and enhancement of an older project that we had. We started from last year. It takes teamwork to accomplish such a project. It's a major accomplishment, I would like to say. To be able to successfully complete this project, it requires planning, good teamwork, patience, being persistent, and try to utilize everything that you have learned in the program. And I think that you have learned enough in terms of instrumentation, programming, computer control, process automation in general. Hopefully you can use these skills when you apply for a job in the real market. And thank you just for sharing the students with us.